Determine all intervals of concave up or concave down, and determine the coordinates of all inflection points, including cliffs, for the function f of x equals x to the fourth minus 3x cubed minus 6x squared plus 10x plus 3. The first thing to do is find the domain. F of x equals x to the fourth minus 3x cubed minus 6x squared plus 10x plus 3 is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative for this. We will start with the first derivative. F prime of x equals, the first term is the power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply it to negative 3, subtract 1 from it. Third term is power rule, bring down the power, multiply it to negative 6, subtract 1 from it. Fourth term is a constant times x, derivative is a constant. Fifth term is a constant with no x, derivative is 0. We can now find the second derivative, f double prime of x equals. First term is power rule, bring down the power, multiply with the 4, subtract 1 from it. Second term is power rule, bring down the power, multiply with the negative 9, subtract 1 from it. Third term is a constant times x, the derivative is the constant, and fourth term is a constant with no x, derivative is 0. We will want to fully factor the second derivative. There is a common factor of positive 6. Factoring that out, we'll leave behind a 2x squared minus a 3x minus a 2, which is a trinomial quadratic and can possibly further factor. Since it is 2x squared, it will factor into a 2x and an x. We need two numbers that multiply to be a negative 2 and add to be a negative 3 when one of them is multiplied by a 2. Negative 2 has factors of negative 2 and positive 1, or positive 2 and negative 1. We will need the 2 to be here and the 1 to be here so that we have a 4x and a 1x, and we will need the 4x to be a negative 4x, so we will want this to be a negative 2, and the 1x to be a positive 1x, so we need that to be a positive 1. It is now fully factored. We can set the numerator of the second derivative equal to 0, and the denominator, if there is one, also equal to 0, and solve for all x's. The first factor, 2x plus 1, equals to 0. We can subtract 1 from both sides and divide both sides by 2, and x will equal a negative 1/2. The second factor, x minus 2 equals 0, we can just add 2 to both sides, and x equals positive 2. We will now check to see which of these are in the domain. The domain is all real numbers. X equals negative 1/2 and x equals positive 2 are both real numbers. They are both in the domain. They are both candidate numbers, and they are candidates to be possible inflection points. We can now draw a domain line, a line representing the domain. The domain has no left end because it begins at negative infinity, and it has no right end because it ends at positive infinity. We can put all candidate numbers on here in order. Negative 1/2 is less than 2 and will come first. Which splits the domain interval into 3 separate intervals. We can pick a test value in each of these intervals. The first interval is negative infinity to negative 1/2. We can pick the test value negative 10. The second interval is negative 1/2 to positive 2. We can pick the test value of 0 in that interval. The third interval is positive 2 to positive infinity. We can pick the test value positive 10 in that interval. We can now test the concavity in each of the intervals by plugging the test values into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. So the best place to plug into is the fully factored version. Starting with the test value of negative 10, 2 times negative 10 is negative 20, plus 1 will be a negative. Negative 10 minus 2 will be a negative. Negative times negative is positive, times that positive 6 will still be positive. We have a positive second derivative. This corresponds to concave up. We can now plug the test value of x equals 0 into the fully factored version of the second derivative. 2 times 0 is 0, plus 1 is positive. 0 minus 2 is negative. Positive times negative is negative, times the positive 6 is still negative. We have a negative second derivative, which corresponds to concave down. We can now plug a positive 10 into the fully factored version of the second derivative. 2 times positive 10 is positive 20, plus 1 is a positive. 10 minus 2 is a positive. Positive times positive is positive, times the positive 6 will still be positive. We have a positive second derivative, which corresponds to concave up. So we have concave up happening in the interval negative infinity to negative 1/2, and union, because it's happening again from positive 2 to positive infinity. And we have concave down happening on the interval from negative 1/2 to positive 2. Right at the candidate number of x equals negative 1/2, we have the concavity changing from concave up to concave down. That will make x equals negative 1/2 be an inflection point. So we have an inflection point at the x-coordinate of negative 1/2. We can find the corresponding y-coordinate by plugging the x-coordinate into the original function. So y will equal f of negative 1/2, which will be negative 1/2 to the 4th power minus 3 times negative 1/2 cubed minus 6 times negative 1/2 squared plus 10 times negative 1/2 plus 3. A negative to the 4th power, because it's even, is positive. 1 to the 4th is 1, and 2 to the 4th is 16. Minus 3 times a negative to an odd power is negative. 1 cubed is 1, and 2 cubed is 8. Minus 6 times a negative squared is positive. 1 squared is 1, and 2 squared is 4. A positive 10 times a negative 1/2, we can multiply the numerators. 10 times negative 1 is negative 10 over 2, which is a negative 5. And then plus a 3. So we have a 1 over 16. The negative 3 times the negative 1/8, we can multiply the numerators. Negative 3 times negative 1 is positive 3, so it'll be a positive 3 over 8. A negative 6 times 1/4, we can multiply the numerators. Negative 6 times 1 is a negative 6 over 4. And then a negative 5 plus 3 is a negative 2. We need to combine all of these together through addition and subtraction, so they will need a common denominator. Each of the denominators divides into 16, so 16 will be the common denominator. We will leave the first term alone, 1 over 16. We can multiply the second term by 2 over 2, which will make it become a positive 6 over 16. We can multiply the third term by 4 over 4, so it'll become a negative 24 over 16. And then we can multiply the negative 2 by 16 over 16, so it'll be a negative 32 over 16. Now that we have a common denominator, we can combine all the numerators together. 1 plus 6 is 7, minus 24 is a negative 17, minus 32 is a negative 49. So we have a negative 49 over the common denominator 16. That will be the corresponding y-coordinate for that inflection point. Right at the candidate number of x equals positive 2, we again have the concavity changing from concave down to concave up, which makes x equals 2 be also an inflection point it has a corresponding y-coordinate that can be found by plugging the x-coordinate back into the original function. So y equals f of 2, which will be 2 to the 4th minus 3 times 2 cubed minus 6 times 2 squared plus 10 times 2 plus 3. 2 to the 4th is 16 minus 3 times 2 cubed is an 8 minus 6 times 2 squared is a 4 plus 10 times 2 is a positive 20 and then plus 3. So we have a 16. A minus 3 times an 8 is a minus 24. A minus 6 times a 4 is another minus 24. And the plus 20 plus 3 is a plus 23. 16 minus 24 is negative 8. Minus 24 more is negative 32. And then plus 23 is a negative 9. So this has a corresponding y-coordinate of negative 9. We have 2 intervals of concave up, 1 interval of concave down, and 2 inflection points, one occurring at negative 1/2 comma negative 49 over 16, and the other one occurring at positive 2 comma negative 9.